So we're going to go ahead and get started. Thank you for joining us today for our SPA with Svelte and Micronaut webinar. I'm Jen and I work with the 2GM team here at OCI. We're happy to have presenting to you today Sergio, Senior Software Engineer and part of the OCI Micronaut Core Development Team. Additionally, we have Mark Volkmann, who's a partner and principal software engineer here at OCI and leads our web development practice. Today, the guys will demonstrate how to combine a UI built with Svelte and a backend built with the Micronaut framework to create fast, powerful, and user-friendly SPAs. As a reminder, please load up your questions into the Q&A section as you have them, and we'll do a live Q&A session at the end and answer as many questions of yours as time allows. We are recording this session and we'll plan to make it available to view on demand shortly after. I believe that's it for me, so I will turn it over to you, Sergio.
Thank you, Jen. Thanks everyone for joining. We have a really interesting webinar today about what I consider a real life scenario where you have like a backend and you have a front end completely deployed, completely independently, and that needs to communicate and needs to share knowledge between basically backend and front end teams. They have to have like clear contract with good API documentation. They have to communicate securely, and hopefully this demo gives you a couple of ideas. My name is Sergio del Amo. I am joined, as Jen said, by Mark, who is gonna give more information later about Svelte. We want to show you today a sample demo application. Essentially, I want to discuss three topics, which I think are really powerful and really easy to configure in Micronaut, which are API security, API documentation, and API versioning. And in order to do that, I'm going to show you the flow of a sample application that we have developed. Then I'm going to show you the code, and we can discuss several aspects. And then Mark is going to tell you about Svelte, and I can show you the Svelte code, which is amazing how little code there is for how much functionality. But first, we wanted to create like a nice demo, not just combining Micronaut and Svelte, but combining an external authentication provider. In this case, we are using Amazon Cognito, which is, but you could be using like something like Keycloak or Okta or Auth0, any OpenID or even Google, logging with Google, any OpenID compatible provider that you can imagine. So essentially, we have three applications. Imagine this in this sample scenario, you could have like a UI deployed maybe in a completely different domain. And then I could have like my API running in a different domain. And for example, Cognito allows you to use like a subdomain of a domain that you have managed via Route 53. You can point it to a Cognito user pool. But essentially, it's like three applications. All of our requests are gonna go from the front end to the backend, and they are gonna specify an API version header, which we can use to basically evolve the API without creating like breaking changes that are gonna make the life of the front end developers more difficult. So this is what why you are seeing here the XAPI version. If we don't specify any authentication, any bearer token, the endpoints in the Micronaut application are going to return a 401. When that's the case, the front end is going to call the login endpoint in the Micronaut application, and the Micronaut application is immediately going to create an authorization code grant time flow, and it's basically going to compose a request. Basically, it's gonna redirect to the Cognito login form. Cognito has a couple of capabilities. Other providers have them as well, which are nice. Which is like you can customize the login form so that it has like the colors of your company, the logo, and certain other things, which basically can make transparent for users that you are using Cognito. Essentially, you have delegated all the logic, or you don't have like to code password reset functionality, multi-factor authentication, all that. Those things are taken care by the external authentication provider, and you basically outsource the authentication part. So the user is gonna enter his username and password incognito. Then it's gonna send basically a code back to the Micronaut application. We are gonna send the code back and exchange it for an ID token and an access token. And in this sample application, what we are doing is we are using the ID token directly and sending the ID token directly to the front end. And the front end in subsequent request is going to use that token to talk to us. And he's going to send us the bearer token. And the Micronaut application, because we have configured the OAuth2 application for Cognito, we are able to take that token, validate the signature, because Cognito and all the other, every OpenID Connect provider, typically they expose their public keys, that the keys that they use to sign the JWT, they expose this in a public endpoint. In particular, Micronaut uses the well-known OpenID configuration endpoint to retrieve information about the authorization server. And in that endpoint, typically the providers tell you can retrieve the keys in this particular endpoint. So we use that to validate the keys. So we validate the signature of the JWT. We validate other claims of the JWT. So for example, that the expiration is still valid. And thus we have created a secure communication channel between the bearer token, between the front end and the back end. I'm going to show you directly in code. I have here in the slides. We can come back to the slides later. So essentially, I have here the backend, and this is my security configuration. I have here basically I have installed Micronaut security with the OAuth2 module as well, and I have here created. So Micronaut supports having multiple OAuth2 clients. I have one here which I have named Cognito. I could have named it something else. And I am supplying the client ID, the client secret, and the issuer as basically as environment variables. The other, and this is all I need to basically create this authorization grant code flow. The other thing that I have configured is I have created a custom login handler that basically I have annotated as primary. So that this is the login handler used. It implements a directed login handler and it's going to be used. And basically what I do is I am, another thing that I have used is I have set here as authentication mode, I have set here ID token. We have, for example, when you don't have like an external front end, but you want like to generate like a cookie, we support, for example, saving the ID token that you receive from an authorization server directly in the cookie. In this case, I am not saving it, but I am still, I want the ID token to be reachable in the custom login handler. And I am taking that ID token. I am basically, if you see here, I am using, this is a Micronaut class. Let me actually make the font a little bit bigger. Sorry about that. So I am using this helper class called URI Builder that is in Micronaut to basically create a, I am redirecting to localhost 5000 in this example, and I am basically supplying a query value parameter with name token, and I am sending the ID token. So this is essentially, this is the part that takes care in the presentation that I showed you before of this last part. So this last redirection here at the bottom, this is taken care by the custom login handler. All this authentication flow that I was showing here, this is automatically done by Micronaut. And also Micronaut has like auto discovery. So it's, as you saw, you don't have to configure anything special for basically connecting to an standard OpenID Connect provider. That's about security. The next thing I wanted to talk to you is about API documentation. And I have mentioned a couple of things. I'm going to show you this directly in the code as well. So Micronaut has, this is an amazing feature. So you may have heard about Swagger. In Micronaut, we have support to generating OpenAPI documentation. OpenAPI is like the open source version of Swagger. So Swagger 2, they created like a foundation, and they now Swagger is the tools to work with OpenAPI, and OpenAPI is the technology. You can think, I sometimes think about OpenAPI as Swagger 3, but essentially it's a way to define an API. And we have a great support in Micronaut to generate this at compilation time. So you actually, this ensures that your Open API documentation is really reflects your code. We have also support for enhancing that documentation with Swagger annotations, which is a set of annotations that the Swagger folks provide. And if I now run here, if I compile my application, if I run classes under build classes meta-inf Swagger, it generates basically a YAML file with my API documentation. There are many OpenAPI solutions to basically create a user interface on top of this API documentation. And I have here, I am using Swagger UI. In order to configure Swagger UI, I have a properties files called openapi.properties in the root of my project, which enables Swagger UI. And I have done a couple of other things. I have here, basically, Micronaut support serving static resources. You can, for example, do like a Micronaut application can serve a JPEG or a PDF, or in this case, a style sheet or an HTML page directly. So I have here, basically, I am defining two static resources, one for the Swagger YAML file itself, and another one for the Swagger UI resources. And I am basically telling that you can access this without being authenticated. And in fact, in the home page of my application, if I go to localhost 8080, I am redirected to documentation. So I have the app here running, I believe. So if I now come here and I do here localhost 8080, I am redirected to the / Swagger UI, and you can see here that I have API documentation. For example, I can click here in API dashboards. It tells me like some description. It tells me like there is an HTTP header required. It tells me that you have to supply a path parameter. It creates an example. Micronaut will do much of this heavy lifting without you specifying any Swagger annotations. But personally, I like to specify the Swagger annotations because you can do things like give more information about, for example, bad responses. So let me show you an example of maybe this one. So I have here a Swagger annotation where I describe like the XAPI version header is a header parameter, and in my controller, I am not binding the XAPI version header. I will talk now more about this because I'm not doing anything with that, but you can do that. In my logic here, I am returning sometimes a 404, and sometimes I am returning a 200. And you can describe this in the endpoints as well. So really nice way to build API documentation is you use Micronaut to generate OpenAPI documentation at compilation time, and you basically put the cherry on top with Swagger annotations. I mentioned here the XAPI version. The idea is that so I have this constant file where I have like version 1 is 1.0. So I am basically telling that this is version 1. So if Mark wants me to modify the response object in a breaking, changing way, what I could do is I could keep this as a version 1 endpoint, and I can create another method annotated with version 2. It will have the same route. Micronaut, if you change the XAPI version header value and you point it to 2.0, will automatically route the request to the 2.0 endpoint. And this is a great way, and especially I recommend people to start creating a versioning policy in the moment they start the APIs, because that allows them to basically evolve them much faster. You could, of course, version your APIs using like a path variable. You could have here like something like B1, but personally, I think it's more elegant the header. I think the header is more elegant. There is people who use, for example, a default version, so that if you don't specify any, you send a default. In some projects, I am enforcing that the version, or you can throw like for example, with a client, we are throwing like an we are even validating that the version that you are supplying is one of the versions that our application understands, and if not, we are like sending a custom error. So really powerful support, and it's really easy to integrate. The only thing that you have to do is you annotate your controllers with the add version annotation, which takes a string, and then you enable versioning here with Micronaut router versioning true. When you communicate with a frontend, chances are that you will have to enable CORS. So I have here enable CORS. So CORS stands for cross-resource origin. And I have basically created a wide open CORS, but you could even like, you could fine grain it only to basically allow CORS access to your front-end application. So in this example, I have enable it wide open, but of course it's completely possible to do that. So we have talked about security, we have talked about API versioning, I have talked about the CORS, and we have talked about documentation. I'm gonna start the app and show you the app running, and then I'm gonna hand over to Mark. So I have here the front end running. So I'm gonna stop the app. I'm gonna stop both the app. So I have here Mark put instruction for me to start the application. So there is no much Svelte code. We can show them later if you want, Mark. I'm gonna run here npm run dev. This is gonna start the Svelte application in local host 5000. You saw it started blazingly fast. I have here a script which sets my secrets environment variables and then runs Gradle run. So I'm gonna do that. This is going to start the Micronaut application, which starts also in 1.5 seconds in localhost 8080. So now what is going to happen is I'm going to go to localhost 5000. Mark is going to detect that I don't have a token, right? So he's going to redirect me to the Micronaut application, and the Micronaut application is going to redirect me automatically to the Cognito application. So the redirection flow is pretty fast, but now we are in the Cognito application, and now I can come here and log in. And this is going to redirect me back to the exchange flow and go back to the localhost 5000 application. And here we are doing an homage to an old dashboard software as a service solution from a Spanish startup called Dashboard, where they will display like widgets in a dashboard. So essentially, if I come here and inspect the code, you will see that in network, if I refresh probably, you see like the request and you will see like Mark is communicating with me securely. He's sending me the basically the ID token. So if I took this token and I came here to JSON-web-token.io, remember a JSON web token is not encrypted, it's just base64 encoded. So I can decrypt it and check the token and see that it's a Cognito token. And it says like the subject, you see my email address, and this is like my Cognito unique identifier here. So seamless integration. We have also wired up the logout. So Mark, I think Mark is going to explain how is he saving the JSON web token, but essentially logging out of this application just means clicking, basically removing the cookie or removing the token from it's not a cookie, but it's, I believe, session storage. So if you remove the token, that's basically logging out. So this service is completely stateless. So if I click here logout, I am automatically logged out, and that triggers basically a redirection to the login endpoint. So I'm gonna pass the baton to Mark, and I have the slides about OpenAPI and cores and versioning, but we have discussed that in code. So, yeah, the floor is yours, Mark.
All right, excellent. Yeah, let's go to the next slide. So Svelte is an alternative to some other web frameworks that you're probably familiar with, like React and Vue and Angular. And a big feature of Svelte is that it's a compiler. It's not a runtime library. And so what this means is that you define your components in .svelte files, and those get compiled into JavaScript. Svelte code is implemented in TypeScript, and you have the option to implement your components in TypeScript if you want, but you can also just use plain JavaScript. But there are no runtime dependencies for Svelte. Another big feature is that it doesn't use a virtual DOM. Frameworks like React and Vue do. And if you look at some of the resources toward the end of my section of slides here, you'll see a talk by Rich Harris where he explains why he believes using a virtual DOM is a bad idea. So Rich Harris is the person that created Svelte. He used to work at The Guardian, and now he works at the New York Times. He's a graphics editor there, and he uses Svelte as part of his work to enable him to put together interactive graphics for their website quickly. Before he created Svelte, he created another framework called Ractive, which is still in use at The Guardian, and it inspired a lot of things that went into Svelte and also inspired parts of Vue. And before that, Rich Harris created the rollup module bundler, which is still very popular today. And by default, that is the bundler that Svelte uses. It's an alternative to things like Webpack and Parcel. Okay, next slide. Okay, so these are some of what I view as the top features of Svelte. First is that you write less code to get things done than you do in the other frameworks. And after you experiment with Svelte for a bit, that'll really become apparent if you go back to the other frameworks, how much more code you're writing. Another feature is small bundle sizes. And so what this means is that the Svelte compiler, when it bundles together the JavaScript for all of your components, you get this resulting JavaScript bundle that has to be downloaded to all of the users' browsers that are running your web app. And it's considerably smaller for a normal Svelte app than it is for apps written in the other frameworks. Svelte uses file-based component definitions. This is kind of similar to the way that it works in Vue, where that .svelte file encompasses the JavaScript logic for a component, all of the HTML that you need to render, and all the CSS for styling that component. And so each component is in one file that combines those things. And the CSS that is in that file is scoped by default. So it means that if you want to say that a button should have a red background, you're only saying that about that one component, not for the other ones, because it would be scoped to that component. And if you want it to be global and affect many components, there's a clear place to put that kind of CSS in Svelte. You put it in the public directory in a file called global.css. Svelte provides two-way data binding. And so that's really great when you're working with forms and you've got things like inputs and selects and text areas and checkboxes, those sorts of things. You like it to be the case that you can have a variable inside your component that holds the value of that particular form input. And you want it to be that if the user changes the value of that input, your variable updates, or if your code changes the variable, the form input changes to match. And so Svelte has that out of the box. I mentioned that you can use TypeScript if you'd like. A big feature for me is the way state management works in Svelte. So in other frameworks, there's ceremony that you have to go through to identify what is it in this component that I consider to be my state. And there are two kinds of state to think about. There's the state within a component and then the state that is supposed to be shared across components. So just thinking within a component, any top level variable I declare within the JavaScript for that component, if I use it in my HTML, then that becomes a part of my state and it's reactive. And what that means is that if I change the value of a variable and I'm using that to render something, then what I render is going to be automatically updated. I don't do anything extra to make that happen. There are some cases where you need to compute a value based on other values. And it can be tedious to set up code in other frameworks to say, I want to watch these certain variables. And then when they change, I want to run this bit of code. But in Svelte, you use the special syntax where you say $:, and then either one line of code or a block of code. And what the Svelte compiler does is it looks to see what are the variables that are being referenced in that statement. And then it watches those for you. And if any of them change, it reruns that block of code. And so there's really interesting things you can do with that. And you should think of this the way you think of cells in a spreadsheet, where if you put a formula in a cell, and then you change the value of some cell that is referenced in that formula, obviously the one that has the formula is going to automatically update. And that's the same thing that is happening here. Then thinking about state shared across components, if I'm holding, say, a collection of descriptions of dogs, and I want it to be that one of my components allows you to add and edit and remove dogs, and then there's another component that's showing a report on all of these dogs. Well, I want it to be that if anything in that collection of dogs changes, all of my components that use it update automatically. And in other frameworks, you use things like Redux and Vuex and NGRX to set up that sort of state management. This is built into Svelte using a thing called stores, and I'll show an example of how that works later, but suffice it to say, it's far easier to use stores than those other approaches. Another benefit is animations. There's animation support built into Svelte that is based on CSS transitions, and so it's very fast. And the URL that I have listed there is from a talk that I gave recently, specifically on animations, showing how in most cases, you're just adding an attribute to some HTML element, and that makes it animate in interesting ways. And then the final feature I want to point out is that if you want, you can compile your Svelte components into web components, which allows them to be used in apps that you've written in other frameworks. Okay, next slide. So if you want to get started using Svelte, it's very easy. There's a command npx that you get when you install npm, and then you run npx dget, and then you're pointing at a GitHub repository, and this one is svelte.js/template. And so what it will do is it will pull down a copy of that repository for you and create a directory with a name that you specify, where I have app name there. So it'll put all those files into the directory, and that's a starting point for a new Svelte application. So then I can cd into that directory, and then I need to install all of my dependencies. And so I run npm install, and then I can start the app with npm run dev, as you saw Sergio do earlier. So that's running in development mode. Of course, if I want to run in production mode and I want this to be optimized, then I can enter npm run build and do a production build, and then npm run start to do that. But in development, you usually use just npm run dev. And then all the tools that you're used to in doing web development, you can use in conjunction with Svelte. So I can do linting of my code with ESLint. I can format with Prettier. I can write unit test using the Jest framework. And then in conjunction with that, use the Svelte testing library. So that's all for unit test. If I want end-to-end test, I can use Cypress that will drive my application the way that a user would. And then finally, I might want to use a tool like Storybook for demonstrating all the components that I've implemented, or making it easy for me to unit test one of my components in isolation from the rest of the application. So you don't have to learn a new suite of tools to start using Svelte. You can use all those tools you're already used to. Next slide. So this is what a Svelte component looks like. You create a .svelte file, and it can have these 3 sections in it. And they can go in any order, but the order you see here is kind of the preferred order. So at the top, I've got all of my JavaScript code. After that, I can have any HTML I want that is what the component is going to render. And then at the bottom, I have my CSS in a style tag. So going back up to the top, things that I might do inside the script tag, I might import some other components that this component wants to render. Or I could import some JavaScript functions that I need to use as part of the logic of this component. And I also declare my props here which are a way that other components that want to use this one can pass data into it. And then down in the style section, recall that I said that the CSS is scoped. So whatever I say there, it's only styling for this component. There's a way I can break out of that to specify global styles, but usually I would put that in that global CSS file. And notice that the script section and the style section are optional. So that means that a valid Svelte component could just be, say, a div tag that says hello world, a single line, and that's a valid component. Next slide. All right, so here's some example code to get us started. I've got my topmost component in the application in the file app.svelte, and you see that it is importing 3 other components. The demo.svelte file we'll see on the next slide. Hello Svelte is that next box going down, and like I described just a second ago, there's a component that only has a div that says hello world. That's a complete component, and so I'm importing that. And then you see that after the script tag, I have a main tag. That's not required, but it's just saying that this is kind of the main shell of the application. Then I have an instance of that hello tag, and you see that I'm not passing any attributes to it. It doesn't require any props. And that alone, that line with the angle bracket hello, that's going to render my hello.svelte component. After that, I've got a form element where I can type in a value for something. And so I have a label with the text name, and then I've got an input. And notice that the input has a bind, and the bind is binding the value of that input to the variable specified in those curly braces called name. And you see that that's declared up in my script tag, and it's set to the string world. And so that means as soon as I start up this app, you're going to see an input after the label name, and it's going to say world inside the input. But now the user can click in that input and change world to something else. And if they do, that's going to immediately change the value of name. But you see on the line after form that name is passed into the hello2 component, which is the next box over to the right. So you see that hello2.svelte accepts a prop called name, and it has a default value of world. So that's the way that you declare props in Svelte. You use the export statement, you declare a variable with let, and you don't have to have a default value the way that I do there, where I set it to world. If I didn't have a default value, that would be saying that that prop is required, and anybody who uses the hello2 component must specify that prop. But this one has a default. But despite that, when I use it over on the left, where you see angle bracket hello2 and then name in curly braces, I'm passing in the value. And so if the user changes what is in the input, that changes the variable called name. The new value gets passed into the hello2 component, and then it renders hello and whatever that name is. There's a box there that says prop shorthand, and what that means is that you could say hello2 space name equals curly brace name curly brace. But that's a common thing to say that you have a variable that happens to have the same name as a prop. And so as a shorthand, Svelte lets you just omit the name of the prop and just give the value, the variable inside curly braces, and it means the same thing. Then we have the demo component, and we'll see that one on the next page. And then finally, some styling I want to apply only to this component. And here I'm just trying to add some space above and below the form. So if we go to the next slide, we'll see what the demo component does. So we weren't passing any props to it. And here you see that the demo component, like the previous slide, it has a script section. There's a style section at the bottom, and then I've got some HTML in the middle. So in my script, I have this variable count that starts at 0, and then I have a reactive statement. And so this is going to set the variable too many to be either true or false. So if count is greater than or equal to 10, it will be true, otherwise it's false. So it starts at false, and anytime count changes, it's going to reevaluate that and assign a new value to too many. So looking at my HTML, I have a button, and below the button, I'm conditionally going to display a paragraph tag that says you've pressed the button too many times. But I only want to do that if too many is true. So that the curly brace pound if, that's the way that you insert conditional logic into your Svelte component. Another thing that we won't look at here is pound sign each, which is how you can iterate over an array to render many different things inside a component. So going to my button a few lines up, you see that it says class : danger. And this is how I can conditionally add a CSS class to an element. And what that says is if too many is true, then I want to add the class danger to my button, but otherwise I don't. And looking down at my CSS at the bottom, you see that anything that has a class of danger gets a red background and a white foreground. So my button won't be red until the value of too many gets set to true, which will be set to true when count reaches 10. Then we have some event handling on the button. So I say, if there's a click event, what I want to do is execute the function that's inside the curly braces. And in this case, because the function is so simple, I'm just specifying it with an arrow function. All I want to do is bump up the value of the count by 1. So every time I click the button, count goes up by 1. It reevaluates my reactive statement up on the 3rd line. Too many might change to true. If it does, then I'm going to display the text, you've pressed the button too many times, and I'm also going to add the danger class to my button. So in the screenshot that you see there, I've already pressed it 10 times, exactly 10 times, and so it's red. Let's see. Yeah, another thing to point out is that the button, its text says pressed, and then there's curly braces, and then times. And so that curly braces, that's called an interpolation, and I can put any JavaScript expression there and it will evaluate that and use that for the text of the button. Okay, next slide. Svelte also has an online tool called the REPL that lets you experiment with Svelte without having to install anything. So it's a great tool. It can even save previous REPL sessions that you've created. So you can have a whole catalog of examples that you have made. Another nice feature is that if you're having problems figuring out something in Svelte, each REPL session has a unique URL, and you could email that to an email list for Svelte and ask someone to take a look at it. And in fact, let me share one of those with you now. I've got a Svelte REPL session open. So I'm going to go ahead and share my screen. Share. Okay. And Sergio, are you seeing my screen? Okay, great. So this is a Svelte REPL session, and I'll zoom in just a bit. This is a small app that computes monthly loan payments. And so I can type in a loan amount and an interest rate and a number of years. And notice if I change the loan amount, my monthly payment changed automatically. Or I can go to my interest rate and start clicking on that. And you see the monthly payments are going up as I bump up the interest rate. Or I could go to the number of years and lower the years. And so my payments are going up. And look at the code over on the left that it took to do this. You're looking at the whole thing here. That is amazingly short. And it's done because I have a number of these reactive statements that are basically saying, looking at this first one, if I change the number of years, I need to recalculate the number of months. But then if I change the number of months, then the denominator in my formula is going to change. And if I change the loan amount or the interest rate, the numerator has to change. And if I change either the numerator or the denominator, then the payment has to change. So all these things are tied together in the same way you would do it if you wanted to do this in a spreadsheet. And then the rest of it is just some basic inputs binding to different values so that if I change the value in this loan input, it changes the loan amount, and that just ripples through all of my calculations. So I invite you to try to recreate the same thing in some other web framework that you might be familiar with. Okay, I'm going to stop sharing and let's go back to sharing Sergio's screen to look at the slides again. So that's the REPL. I highly recommend giving that a try. to get started in using Svelte. I mentioned stores as a great way that you can share data between components. The demo app I showed doesn't use stores, but it's really a significant feature of Svelte, and so I want to talk about this just briefly. There are 4 kinds of stores, but by far the most common kind is just to create a writable store, which means all your components can subscribe to it so that they're notified if there are changes to that data, and they all can change it. And they can do it by calling set on the store and giving it a new value, or they can call update and pass it a function where they'll get the current value and they can use that to compute a new value. You also can create a readable store, and that's for cases where you want to handle what the value of the store is, but you don't want your components to change it. So it doesn't mean its value can't change. It just means that the components can't change it. So it might do something like make a REST call, and it could even make the REST call periodically. Maybe once every 10 minutes, it makes this REST call and updates its own data. And when it does, any components that care about that data can update what they're rendering on the screen. A derived store says, I want to take values from multiple stores and combine them in some way. Maybe there's a formula that I use to calculate value of the derived store from other ones. And then a custom store lets me customize the API for getting to the store. So if you think about a writable store that's going to hold a counter, for example, if I set that up, now any of my components can set the value to anything they want. But what if I want to make it so that you can't do that? You have to just tell the store, I'd like you to increment or decrement or reset to 0. So with a custom store, I can avoid exposing set and update and just expose the methods I want to control the ways in which components can modify the value. Okay, next slide. So if you want to use a store, the simplest way is what I'm showing in the first box. I import the writable function from svelte/store, and then writable is just a function, and I call it and I pass it the initial value. So here, if I want to hold an array of objects that describe dogs, I could say, well, the array should start off being empty. And now any of my components can add to that array, and other components that care about it will get notified and they can update themselves. If I want to make it a little fancier, like for example, let's say I want to get the initial set of dogs from a REST service. Well, I can do it in the second way where I pass it not only an initial value, but also a function. And that function can be async if I want it to. In the case of calling a REST service, that's convenient. So now I can use the fetch API and make my REST call. Then I can extract JSON out of that. Of course, I'll want to add a little bit of error handling in there. But when I finally do get the value, I can call set, which is passed to my function. And that gives me the data in the store. So it can start off, for example, being an empty array. And then when I get the data from the REST service, I can replace that empty array with what I got back. Okay, next slide. So that shows how you set up creating a store. And then if you want to use one, there are 2 ways to do it. There's a way that is a bit tedious, and then the way that you really want to do it. So what has to happen is that somehow you've got to subscribe to the store. And if you do that in the way that you see on the 5th line there where I'm calling subscribe, you pass to subscribe a function that's going to get invoked anytime the value of the store changes. So it'll pass you the new value, and then you can do whatever you want with it. And in my case, I'm just assigning it to my local variable dogs. And when I call subscribe, it gives me back an unsubscribe function. OnDestroy is a lifecycle method that gets invoked when my component is removed from the DOM. And so in that case, I want to call unsubscribe. But that's a lot of ceremony to go through. So I can simplify this if when I import the dog store, I just make sure that every time I reference it, I do it with a $sign in front of the name. And if I do that, Svelte will automatically subscribe to that store, and it will automatically unsubscribe when that component is removed. So that really is the way that you want to do it, is just throw a $sign in front of your store variables. Next slide. So here are some tools related to Svelte that you might want to consider. First is that the VS Code IDE has a really good Svelte extension that helps you in writing your code. Second is Sapper, which is a framework that builds on top of Svelte. It's similar to the way that Next builds on React, and Gatsby does a similar thing. So Sapper provides routing between your components so that you can map URLs to pages of your app. It gives you server-side rendering of the first page that you visit. It gives you code splitting, which means that when you visit a page of your app, you're only going to download the JavaScript for that page. And then when you navigate to another page, it'll then download the JavaScript for that page. So this is great because even though Svelte bundles are really small, if you've got an app with, say, 20 pages in it, you can make it even smaller if it's the case that it only downloads what it needs for each page. Now it's just for the initial page, you're downloading 1/20th of the JavaScript code. It can also be used to build static sites. But having said all of this, I would caution you to not get started with Sapper today. And that's because about 2 months ago, the Svelte team announced that they're going to stop development of Sapper and roll almost all of its features into Svelte itself. And so that's a thing being worked on right now under the name Svelte Kit. And I would expect that in the next month or so, a new version of Svelte will come out that will have all of those features wrapped into it. Svelte Native is the way that you can use Svelte to implement a mobile application that runs on Android or iOS. It builds on top of NativeScript. And so it's not implementing all of these things from scratch. It just uses what's already in NativeScript and lets you use Svelte syntax for doing that. I mentioned Svelte testing library earlier for implementing unit test and then using Storybook to demonstrate your components. Next slide. Here's some resources you might want to check out if you're interested in learning more about Svelte. The first one, Rethinking Reactivity, is a talk by Rich Harris that I mentioned where he explains what it is he doesn't like about Virtual DOM and what drove him to add the features that he did in Svelte. Then there's the Svelte homepage with lots of great resources, including a link to the REPL. There's a Discord chat room where you can go to ask questions. The GitHub repo, some other sites that have Svelte resources. Okay, next slide. So this is the component that we implemented for the application that Sergio described. So the outermost component, the app component, is in charge of rendering everything. And mainly what it's rendering is that logout link in the upper right corner, and then the counter trend component. And the counter trend component has a few parts to it. There's the title at the top. There's the last data value. And so what we're showing here are exchange rates between US dollars and euros. And so in big numbers there, it's showing the last data value. Then there's a subtitle under that to explain what it is that we're showing. It's a bit hard to see, but there's actually a faint histogram at the bottom of this. And so the numbers there, like the 19 I'm pointing at, that's a day of the month. And we'll see on the next slide that you can hover over one of those bars to see some detail on that. And then that gray number at the end there was showing the delta from the last value it was showing and then the one right before that. So on this next slide, we're going to walk through kind of the sequence of actions that happen here. And so when the Svelte app starts up, it checks to see, is there a token related to logging in that is either passed to it in a query parameter or sitting in session storage. And if there isn't, then it's going to make a call using Cognito to try to get that. So if there's already a token, it calls load data, and that's going to get all that data for the histogram that I'm showing, and it will pass that to the Svelte component so that it can render it. So that load data function uses the fetch API, similar to what I showed when I talked about Svelte stores, makes an HTTP request to 2 different REST services, and both of those require an authorization header that has a bearer value. The Svelte login function, it just redirects to a URL for the Cognito login, and then that takes care of rendering a login form for us. And then after a successful login, that Cognito login page is going to redirect back to the Svelte app and then include that token as a query parameter. So the Svelte app will then store that token in session storage, and then that's going to make it so that if the user refreshes the browser, they don't lose that token. They can just keep working. when you click that login link that was in the upper right corner, it's going to remove that token from session storage and then go back to the logout URL. So that's the flow of everything through the Svelte app. And then in this view here, you see that I'm hovering over one of those bars in the histogram, and then it lights up to show me the actual value. This is done using SVG elements, in particular using the rect and the text elements. It's a great way to draw things inside any web app, including a Svelte app. Okay, next slide. So I think Svelte is a really great alternative to using frameworks like React and Vue and Angular. For me, a big part of the appeal is just that I feel like I'm writing a lot less code to get things done. Everything seems so much more clear, and especially the state management is appealing to me, how easy it is to manage state both within a component and then across components. And I love Svelte so much that I took the time to write a book on it. And so you see here a picture of the cover of my book. So I encourage you to go check that out and learn more about Svelte. And I think that's my last slide, Sergio. Yes.
Yeah, thanks, Mark. Yeah, one of the cool things of working at OCI is that we have people with really different profiles, and Mark is an amazing front-end developer. So if you are interested in learning about Svelte or learning about different front-end options for your projects, don't hesitate to contact us, and don't hesitate to contact Mark about anything Svelte related, because he's really great at. If you have questions about anything Grails or Micronaut related, don't hesitate to contact OCI as well, because we are the home of both open source frameworks, Grails and Micronaut. We have some time for questions. So if anyone, let me open the Q&A and see if I can able to monitor it here in another monitor. So we have, can we get the projects including source code for Micronaut and Svelte application demo today? Yes, you can, Don. I will share that. We have that already in GitHub. It's currently in a private repo, but we will do that. Does Micronaut support OAuth run types client credentials? Yes. Joao, it's actually a feature that we introduced in Micronaut 2.2. So that's fresh out of the oven. We actually support client credentials in a couple of interesting ways. You can have like different client credentials per OAuth to client that you have defined. You can like get a bin, client credentials. I believe we call it client credentials client, but you can also like use like an automatic propagation. So check the security docs. As I said, is available since Micronaut 2.2. Does Micronaut support .conf file for the configuration? Micronaut supports YAML files, .property files, and .groovy files for configuration. And we support also a Kotlin configuration as well, but I don't remember the name anymore. But we don't support .conf files for configuration. Don has a question. Can the application define and pass the claims for the users to the OAuth provided and have the OAuth provider generate the JWT with those claims? Yeah, so the way it works, the way is you request the scopes that you want to be granted, right? So you tell your OAuth provider, I want, I don't know, like ID token, but I also want the email and I want the profile of the user. So then it's up to the user if he wants to allow us to share that information with you. And depending on the things that the scopes that you request, different claims will be on the client. So yeah, will Grails and Micronaut be merged in the future? I don't think so. So Grails is built on top of a Spring Boot, and Micronaut is not built on top of Spring Boot. Micronaut is a completely different framework. Grails 4 has a really nice feature, which is the Spring Boot application context allows you to define a parent context. and the parent context of Spring Boot is set to be a Micronaut application context. So what that means from a developer point of view is that you can use any Micronaut component which is not HTTP server related directly in your Grace for applications. So if you have, if you want to use Grace, but you want also to benefit from Micronaut features, you can absolutely use that. So we would like to think of Micronaut as a foundation framework. So it's not just a framework for building like server applications, but for building any other application that you can imagine, command line applications, serverless application, etc. I am interested in the curious if you folks would consider offering a follow-up sessions to go deeper. We will share the code. Not sure about the follow-up session, but we are of course interested in engaging with the community as much as possible. How is profiling done in the Micronaut application? In this application, I don't have any profiling done. We have like some. So if you go to docs, so Micronaut is really modularized. We have some solutions for that, but I am not using any profiling features in this particular application.
All right. Thank you guys so much. I think we've gotten all the questions answered that have been posted to our Q&A so far. So thank you guys again. And we look forward to having our next webinar, and we will be posting when we will be having our upcoming events for 2021. So stay on the lookout for that. And thank you everyone for joining us, and have a great day.
Yeah, thank you everyone for joining. We wish you all happy holidays. Stay safe. We will be here for a couple of minutes for if there are any other questions. And if you want to reach us, we are available, of course, on Twitter and via email as well. So, yeah, reach to Jen or myself or Mark, and happy to talk to you. So, Peter, thanks you, Mark, for this clean and crisp Svelte introduction.
Great.
For those who are still on the line, this is the Svelte code. As I said, quite amazed of how little code there is. So this is the two components that Mark was talking about. It's nice also the decoupling of each component with its own JavaScript and CSS. I think that's a really nice encapsulation. Let me actually grab a link to the client credentials support that we added. Security. Client credentials. Where will the link to the repo be posted? Thanks for the great presentation. I guess, so typically what we do after webinars, Peter, is we create like a landing page where we set the video, we embed the video, and also we link to the slides. So probably there will be like a link to the source code probably.
Yes, I'll send out a blog post with the link to the recording and a copy of the slides, and we can put any additional information in there that you guys might need.
Yeah, probably the best thing to stay on top of that is if you subscribe to the newsletter, Jen will typically link to those blog posts in the newsletter directory. So that's probably the easiest.
All right, thanks, Sergio. So I think that we will go ahead and end the meeting because we haven't seen any more questions or comments come through. So for those of you who are still on, thank you, and we'll see you next time.
Yeah, thank you. Bye-bye.
Bye.